Good morning. In this chapter, we will study about the structure of the atom. In the previous chapters, we studied about the atoms and molecules. The structure of the atom is still complicated and scientists' investigation is in progress. So, we will try to study about the structure of the atom in this chapter. Atoms have three types of subatomic particles. They are electrons, protons, and neutrons. Electrons are negatively charged, protons are positively charged, and neutrons have no charge at all. The mass of an electron is 1 by 2000 the mass of a hydrogen atom, and the mass of a proton is equal to the mass of a hydrogen atom and is taken as 1 unit. The mass of a neutron is equal to the mass of a hydrogen atom and is taken as 1 unit. In 1900, J.J. Thomson discovered the presence of negatively charged particles. Those are known as electrons in the atom. Because already in 1888, E. Goldstein has discovered new radiations in gas discharge, and these are known as canal rays, and that was protons. These positively charged particles were discovered before the discovery of electrons, and in the latter, after 32 years, the Chadwick has discovered that the presence of particles these are known as neutrons. Different scientists tried to how these particles are present in the atom. First of all, Thomson tried to give the structure of atom. Thomson has tried to give the structure of atom. According to Thomson, an atom is similar to Christmas pudding. So this model is also known as plum pudding model. Plum pudding model. The pudding had positive charge and the electrons have negative charge, were like plums on the pudding. He proposed that an atom consists of a positively charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude, so the atom as a whole is electrically neutral. You can see the plum pudding model. Here you can see the whole atom is as positively charged and electrons are embedded in it. After all, this plum pudding model was discarded. All scientists said it will be not possible. So, the Rutherford has given a model. This is known as Rutherford's alpha scattering experiment. As per Rutherford alpha scattering experiment, Rutherford allowed a beam of fast moving alpha particles having positive charge to fall on a thin gold foil. He observed that most of the alpha particles passed straight through the gold foil. Some of the alpha particles were slightly deflected by small angles. Very few alpha particles appeared to be found. Most of the alpha particles are undeflected. A few alpha particles are slightly deflected. A few alpha particles are deflected. Then conclusion from Rutherford alpha experiment that most of the space inside an atom is empty. because most of the alpha particle passed straight through the gold foil, and the atom had a small nucleus having positive charge because some of the alpha particles having positive charge were slightly deflected by a small angle. The size of the nucleus is very small compared to the size of the atom because very few alpha particles appear to rebound, and most of the positive charge and mass of the atom is in the nucleus. So, the Rutherford model of an atom has a positively charged nucleus at its center, and most of the mass of the atom is in the nucleus. The electrons revolve around the nucleus in different angles. The size of the nucleus is very small compared to the atom. And what was the defect of Rutherford model? Because this model was also discarded. And any particle in a circular orbit would undergo acceleration. You can move and see. In the circular motion, there should be acceleration. And during acceleration, the charged particle would radiate energy. So the revolving electrons would lose energy and fall into the nucleus, and the atom would be unstable. We know that atoms are stable. Here you can see the negatively charged electrons in orbits around the nucleus. They are revolving. After some times, they will again, after losing the energy, they will come in the nucleus. Again, Niels Bohr has given model of an atom. As for the Bohr model, he said that atom has a positively charged nucleus at its center, and most of the mass of an atom is in the nucleus. The electrons revolve round the nucleus in special orbits called discrete orbits. These orbits are called shells or energy levels and are represented by the letters K, L, M, N, etc. or numbered as 1, 2, 3, 4, etc. While revolving in the discrete orbits, the electrons do not radiate energy. You can see K equals to 1, L equals to 2, M equals to 3, and N equals to 4, as so on. So, how electrons are distributed in different cells? The distribution of electrons in the different cells was suggested by Bohr and Bury. This is also known as Bohr-Bury scheme. The rule for the Bohr-Bury scheme is that the maximum number of electrons in a cell is given by the formula, that is 2n square, where n is the number of cells, that is 1, 2, 3, 4, etc. For first cell that is K cell, in the K cell how much electrons will be filled? You can see that is n equals to 1, 2n square, 2 into 1 square, it means 2 electrons. In L cell it would be 8 electrons, in M cell it will be 18 electrons, and in N cell it will be 32, and so on. The maximum number of electrons can be filled in the outermost cell. Remember, maximum number of electrons filled in the outermost cell will be 8. That should be not more than 8. And how it will be 8, you will study in further classes. Electrons cannot be filled in a cell unless the cell is filled. First K cell will be filled, then L cell will be filled, then M, and then N, as so on. Composition of the atoms of the first 18 elements you can see, and what is the atomic number, what is the mass number, you will study in this chapter. And here you can see the hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, etc. First remember the symbols of the first 20 elements, as well as the atomic number also remember. In the question paper you will get atomic number, but there is need to be remember the atomic number of first 20 elements. So as per the atomic number, the number of protons of that particular element will be clear. Atomic number will be equal to the number of protons, and number of protons will be equals to the number of electrons, and the mass number is the number of proton and number of neutron. So the as we know that the mass number, we can also get the number of neutrons. How this atomic number is distributed in these cells, you can see that first K cell is filled, then in helium K is filled, K contains only 2 electrons, and in L cell there will be 8 electrons. When outermost orbit filled with 8 electrons, then next electrons came into the next orbit. In M cell, after writing this distribution in different KLM cell, you after practice you will also know how the electrons are present in different cells. You can see the atomic structure of the first 18 elements. Hydrogen, 1 proton and 1 electron. Helium, 1 proton and 2 electrons. Lithium, 1 and also 3 electrons. Likewise, first 14, all these 14 electrons you can see the first 18 elements, how electrons, protons and neutrons are distributed. Very important thing that valency is the basis of the chemistry. If you remember or if you learn how to get the valency of the element, you will remember or you will understand the things of chemistry. Valency is the combining capacity. What will be the combining capacity of an atom of an element? The electrons present in the outermost shell of an atom are called valence electrons. Are called valence electrons. If an atom's outermost shell is completely filled, they are inert or least reactive, and their combining capacity or valence is 0. On the inert elements, that is helium, neon, argon, krypton, xenon and radon, helium atom has the 2 electrons in the outermost shell, and the atoms of other elements have 8 electrons in their outermost cells. Atoms having 8 electrons in the outermost shell is the octet configuration that is stable. If an atom's outermost shell is not completely filled, it is not stable. It will try to attain stability by losing, gaining or sharing electrons with other atoms to attain octet configuration. The number of electrons lost, gains or shared by an atom to attain octet configuration is the combining capacity or valency of the element. Hydrogen, lithium, sodium atoms can lose easily 1 electrons and become stable, and they get 8 state, that is octet configuration, so their valency will be 1. Like magnesium, calcium, etc., these can lose easily 2 electrons, so its valency is 2. Aluminium can easily lose 3 electrons, so its valency is 3. Carbon shares 4 electrons, so its valency is 4. As well as fluorine can easily gain. They were losing, but fluorine can easily gain 1 electron, or chlorine can easily gain 1 electron, so valency is 1. Oxygen can easily gain 2 electrons, so its valency is 2. Nitrogen can easily gain 3 electrons, so its valency is 3. Likewise, we can get the valency of every element. When we will learn the valency, we can write easily the formula of the compound. So very important that this is atomic number and mass number. Already I discussed at the some extent what is atomic number and mass number. Atomic number is denoted by Z and mass number is denoted by A. Remember this. Atomic number is denoted by Z and mass number is denoted by A. The atomic number of an element is the number of proton present in the nucleus of the atom of the element. Remember that. Number of proton is the atomic number, not number of electron. Number of electron will be equal to the number of proton, but number of proton is the atomic number. All the atoms of an element have the same atomic number. Hydrogen atomic number is 1 proton. Helium atomic number is 2. It has 2 protons. Lithium atomic number is 3. It has 3 protons. The mass number of an element is the sum of the number of protons and neutrons. That is also known as nucleons. And the electron is denoted by a small e, proton is denoted by a small p, and neutron is denoted by n. The mass of an atom is mainly the mass of the protons and neutrons in the nucleus of the atom. You can see the carbon has the mass number 12. It contains 6 protons and 6 neutrons, so its mass is 12U. Aluminium mass number is 27, 13 proton and 14 neutrons, so the mass is 27U. Sulfur mass number is 32, so 16 protons and 16 neutrons, so the mass will be 32U. In the notation of an atom, the atomic number and mass number are written as mass number, that is A, and atomic number is Z. So likewise, when the element is X, and the above we will write X, A left hand side, and atomic number Z in the left hand side below the symbol of the element. Again, we will learn the one more topic, that is isotopes. Isotopes are atoms of the same element having the same atomic numbers but different mass number. Same element having the same atomic number, that will be the number of protons will be equal in all forms, but the number of neutron will be changed. Here you can see in the isotopes of hydrogen. Hydrogen has 3 isotopes, that is protium, deuterium and tritium. Protium, hydrogen 1H1. Here deuterium 2H1. Tritium, that is 3H1. Here the number of protons in all 3 forms are 1, but number of neutrons are different. In protium there is no neutron, in deuterium there is 1 neutron, and in tritium there is 2 neutrons. Likewise, you can see carbon has two isotopes, that is carbon 12 and carbon 14. Both of them contain 6 number of protons, but their number of neutrons has changed. Carbon 14 contains 8 number of neutrons, but carbon 12 contains only 6 number of neutrons. Likewise, isotopes have many examples for you. Also learn the isotope of chlorine, that is 37 and 35, and also get how much neutrons and protons are in both isotopes. Last topic is isobar. Isobars are atoms of different elements having different atomic numbers but same mass numbers. These pairs of elements have the same number of nucleons. Calcium atomic number 20, argon atomic number 18 have different atomic numbers but have same mass number. You can see calcium and argon. Their number of mass number is same as 40, but their atomic number is different. They are 20 and 18. So their number of proton is changed, but their number of neutron is same. We can get also in iron, in the case of iron, that is Fe, and nickel, that is Ni. The both the cases, the atomic number is 26 and 27, but their mass number is 58. So now, after the learning isobar, this chapter has finished. Thank you.